We're going to be looking at example 3 in our section 4.1 notes. In example 3, we're given that angle C is 65 degrees, side C across from angle C is 8, and then side B is 10. So this is a side-side angle triangle. So this case of triangle, you can either have 0, 1, or 2 triangles. That's something to note before you get started. So what we would like to find in this case is angle A. We'd also like to find angle B, and then we'd also like to find side A across from it. Those are our 3 unknowns. All right, so to get started here, it makes sense to find angle B first. So using the law of sines, side B is 10. We're going to put 10 all over the sine of B. And then we know the information for C. So we're going to set that equal to 8, which is side C all over angle C, which is the sine of 65 degrees. So if we go ahead and cross multiply to clear the fractions, we get 8 sine B equal to 10 times the sine of 65 degrees. Next, divide by 8. So we get sine B is 10 sine 65 degrees divided by 8. Okay, of course you could reduce those, really not necessary. We're still trying to solve for B, so take the sine inverse of both sides. Remember, when you take the sine inverse next to the sine, they cancel. So here we're going to get B equals, and then we have the sine inverse of this expression. Okay. All right, so you can go ahead and evaluate this and put this in your calculator all at one shot, or if you want to, you can look at the expression inside the parentheses. So if you go ahead and do it that way, if you enter this part into your calculator, you'll get 1.13. That gives you a better idea of what's happening. The sine can't be over 1 because of the way the sine function is drawn. So if you enter this into your calculator, you're going to get an error. So this tells you that this is not possible. Okay, which means that there are no triangles. So that is our answer for example 3.